Hello. In this video, we're going to focus in on that relationship between the exponential and logarithmic equations. So in the last video, we looked at this conversion, converting between y equals b to the x, and that being x equals log base b of y. So with this comes some very nice consequences. Let's say we have this, log base 6 of x is equal to 2. Well, we don't really know logs right now. So maybe if we converted this, using this relationship, we might be able to figure out what x is. So, this base becomes the base of the exponent. This outside number becomes the exponent, and that's equal to the inside. And now in this form, it's very obvious what x is. X is 36. So let's try that again. Log base 14, so this is our base, to the negative 2 is equal to x. Now if we remember, negative exponents mean the same thing as flipping it, and 14 squared is 1 over 196. So again, we can see if we have a log and we're not really sure how to find this x, we can convert it to the exponential form and solve. And this works in reverse as well. Now, you may be able to look at this and say, okay, well, the square root of 64 is 8. Well, let's pretend for a second we didn't realize that. In order to convert it to x equals log base b of y, this x is what I'm trying to solve for, and that's log base 64 of 8. Now I promised in the last video that I'd show you how to put this in your calculator. We would use something called the change of base formula. And what that says is, if I have log base b of some number a, I could write that in my calculator as log a log b. And I could put that in my calculator as ln a. Now, log a and natural log a, these don't have the base written. So when we don't write a base, it could mean one of two things. If I just have log, that means the base is 10. The same way as our decimal system, everything is base 10. And now with logs and exponential functions, there's one other very important number, and that's the number e. Now, e is 2 point something, and just like pi, it's a transcendental number. It's a number that doesn't end, it is irrational, and it's not the solution to a polynomial equation. Now, that's not important. All we need to know is it's like pi, and it's just about 1 less than pi. It's about 2 point something something something. So, using this change of base formula, we can look at this as log of 8 divided by log of 64. So now if we're putting this in our calculator, we would get negative, no, not negative, we would get 1/2. Okay. And we knew that the square root, which is the same thing as saying something to the 1/2, the square root of 64 is 8. So now let's see what happens when we have something a little bit more complicated. So again, we're solving for x, and that's log base 9 of this 1/81. So if we're just relying on our calculator to do this, we would rewrite this as a log of 1/80. Log of 1/81 divided by log of 9. And we put that in our calculator and it would give us -2. And you could have put that in as natural log of 1/81 divided by natural log of 9. It'd still give you the same number. Now, you may have been able to do these two in your head. Maybe you even knew that log base 6 of 36 was 2. The whole point of this section and what we're building to is to be able to do something like this. 10 to the x equals 1/81. Now, 10 to some power, to some integer, is not going to be 1/81. But we can still use these same rules, this same conversion, to estimate what this is with a calculator. So we'd be able to plug this in a calculator and be able to figure out what this value is. And that is the whole point to learning how to do these conversions. It's to build us up so that we can solve these weird exponential equations. But for now, we're going to stick with these nicer equations that come out with either some very nice fraction or an integer. So that's everything we need to know right now about converting between logarithmic and exponential forms.